Welcome to IDEA StatiCa tutorial. We will show you how to use IDEA StatiCa connection to model, design, and check a general 3D joint. Let's launch IDEA StatiCa and select Application Connection. Here, we create a new project. The wizard opens and we select the 3D frame and the topology one column with two beams. We start by defining the geometry. A column and two beams were generated. First, we create a general cross-section for the column member SL by clicking on Insert New Item. Here we go to the tab Welded, Composed, and select General Steel Cross-Section. We begin composing the cross-section by selecting the I sections and HEB 600 from the library. Then we continue by clicking on Add New Entity. Select the sections T and edit the shape to HEB 500. We make additional copy of this T section. We can continue adding more shapes from the library to create the desired cross-section. Or we can also import any shape from a CAD drawing. For both the T sections, we set the master component number to 1 HEB 600 and insert points to 8. We also input the rotation angles of 90 and -90 degrees and the distance from Z-axis as 7.75 for both T sections. By modifying values in this tab, we finish the cross-section composition, and by clicking OK, we close the editor. We check the geometry in 3D window and modify the column length to 600 millimeters. For the member B1, we set the cross-section to HEB 280 from the library and make it inclined by changing the pitch angle to -6 degrees. For member B2, we set the cross-section to HEB 180 and change the direction to -90 degrees and rotation to -6 degrees. We add a new member M4 by clicking Add New Entity, set its cross-section to HEB 280 from the list, and change the direction to 180 degrees and pitch to 6 degrees. Then we add another member M5. Set its cross-section to L100x8. Change model type to axial loading typical for hinge connections and change the pitch to -40 degrees. Let's continue with load effects. One load effect was automatically added by the wizard. Here, we fill the table with previously calculated forces and change the position of forces on member B2 to bolt to ensure zero moment in the hinge connection that we will design. Next step is the design. To model connection between members, we select Add button and pick the desired operation. First, we select the cut of member operation to lengthen the column and input an offset of 18 millimeters. Next, we add the Endplate operation. Select the default bolt grade as 8.8 and default bolt size to M20, specify M4 as member 1, set thickness to 20 millimeters, dimensions to 2 profile, top offset to 15 millimeters, and bottom offset to 150 millimeters. We adjust the bolt's position by filling the layers figures. Set welds thickness to 4 millimeters and select double fillet welds. Then we copy the end plate operation also for the member B1 and change its parameters. We continue with adding a fin plate operation for member B2. Set the member part to web 1, thickness to 8 millimeters, modify gap, overlap, and offsets, and change bolt size to M12. We finish the design by adding and adjusting a gusset plate operation. We set the member to the bracing diagonal M5 and modify the connecting plate to be related to member B1 and the end plate EP2, change thickness, width, and depth. We then add a gap of 30 millimeters, set alignment to rear and connection type to bolted, change the plate weld thickness and weld type, and change the bolt size and position. At last, we go in the editor of the current operation to edit the gusset plate shape by adding a bevel operation and setting dimensions and position of the bevel. Now, we can see the whole joint created. In the next step, we move to the check. We start nonlinear analysis. Analysis model is automatically generated, calculation is performed, and we can check the results. As a default display, we see the overall model colored according to traffic lights. To quickly reorganize which part of the joint is safe or not, we activate equivalent stress, bolt forces, mesh, and deformed to get a full picture of what is happening in the joint. Values of bolt checks and forces together with check equations are displayed in the table bolt anchors. Equally, there is a tab for welds, etc. The final step of a project is to generate the report. IDEA StatiCa offers 3 types of reports: one line, one page, and detailed. We choose the detailed report that contains materials, geometry, and all the checks. We can also add a bill of material and theoretical background. We modeled, designed, and checked a complex 3D joint. Visit our website ideastatica.com and try it yourself. IDEA StatiCa. Calculate yesterday's estimates.